to our YouTube channel, and in today's topic we are going to be looking at determining the amount of current that is required for the job. Determining the amount of current required for welding. In other words, selecting the amount of current that is required for the job. Now, just like in ironing, pressing, when you're pressing your clothes, your shirts, when you turn on the iron, you actually turn the knob to a certain temperature that will be okay to straighten the fabric properly. If the temperature is too high, you discover that it's going to burn your fabric. If the temperature is too low, you discover that it will not be able to straighten the fabric properly. But if the temperature is at the proper range or at the proper temperature, you discover that it will be able to give you the desired result. So also in welding. Now, before you start proper welding, you're supposed to determine the amount of current that is enough for you to weld with certain type of filler rod, with certain type of base metal, and certain thickness of base metal. So all these are the factors that interplay when you want to determine the amount of current that is required for the job. Firstly, you must have determined the type of filler rod, that's the type of electrode you're going to be using for that job. Now, so many persons will tell you, okay, there's a chart for it, so and so filler rod with so and so thickness requires so and so amount of current for such a kind of thickness. If 6010 requires so polarity, so current and all that. That's actually true. Now there's a chart for it, but then the manufacturer made this very easy for us in a way that in the pack of the electrode, you will see what we call the range of currents for that use for the electrode. The manufacturer tells you that, okay, for an E7018 electrode of 2.5 millimeters, you have a range of current from probably 80 to 100 amps, and that's the range he gives for that particular diameter of the filler rod. Okay, he also tells you that for an E7018 10.2 mm, he tells you that, okay, this is the range of current that should be okay for that electrode. Now, you have to also put in consideration the thickness of the base metal. You have to put that into consideration as well. What is the thickness of the base metal? And of course, you know that the diameter of the filler rod should not be more than the thickness of the base metal. All these are factors that you should be able to know. So, now, when you have that range of current, in fact, in the pack of the electrode, you also have the polarity as well. It tells you that for so and so electrode, this is the kind of polarity that is required to use. You see that he tells you that you're going to use an AC polarity, that is an alternating current, or he tells you that you're going to use the direct current positive or the direct current negative, in addition to the range of current that you have. For example, you have 80 amps to 100 amps for 70-80 2.5 mm electrode. Now, this is the range at which this electrode is expected to be able to melt. Current to be able to flow through it and then melt the electrode. Because you must understand that in the process of welding, the core wire in your electrode also has to melt. It's part of the consumables. So it also melts and is also added to the puddle. So this is the range of current at which you'll be able to achieve that. You understand? So now, within this range of current, there's what we call the optimum. I call it the optimum current. Let me tell you the optimum setting. Now, this optimum current is achieved between this range of current. So you achieve this optimum current between this range of current, and I call it the current at which the electrode will be able to perform its best. which as a welder, you'll be able to achieve the best value of the electrode, in the sense that you'll be able to have, a steady arc. You'll be able to have, what do you call it, the covering bond properly. You'll also be able to achieve penetration and all that. So it's left for you now as a welder to be able to check what is the optimum current. And they usually tell us as a guide, they say, between this range of current, if you want to find the optimum current that you should do, you should look for the middle between this range of current. You should set the current between this middle, and then you should try to initiate an arc. And then you look out for the appearance of your bead. And then you look out for the arc. How fast does this molten metal form? That tells you the rate at which it melts. So if it melts very fast, it means the current is high. If it melts too slow, it means the current is low. Now, if it melts, if it's at its normal current, that's the optimum current, you discover that the melting will be okay. Sparkles will not be much and all that. So that's how to determine the amount of current required for the job. Have the range of current. Now, within that range of current, look out for the optimum current at which you'll be able to achieve the best. Now, as we proceed, I was asked a question on YouTube, and I want to use this opportunity to give a reply to the subscriber that asked the question. He said that we should be able to talk about the effect of currents. So here we'll establish that when you have a low current, it will be difficult for you to achieve penetration. Your metals will just mold up. It will be very difficult for you. That's one of the effects of current, poor low current. Now, but when you have a high current, you have deeper penetration. But at the end of the day, you have what we call bond tree. Most times we call it troublesome bond tree. You have bond tree. A situation where the keyhole becomes wider than it's supposed to be. And now voltage as well plays a very important role. We say we have the arc voltage, we have the opening circuit voltage, and we have the striking voltage. We all mentioned this in one of the videos. Now, you should understand that your welding machine is made up of a transformer. Now, the transformer of the welding machines is divided into two. We have two types of transformer. We have the step-up transformer. We also have the step-down transformer. Now, the step-up transformer, what does it do? It means that the voltage that comes into that transformer is low. So when the voltage comes into the transformer, what does it do? It steps the voltage high. So if maybe you have 80 volts, 80 to 100 volts coming into that transformer, at the end of the day, your input is 80 to 100, but your output will be more than 80 to 100. So it steps it up. But for the step-down transformer, what it does is that the voltage that comes in, they have to have 210 to 230 volts coming into, or 230 to 250 volts coming into the welding machine. The transformer in that welding machine, what it does is that it steps it down to 80 to 100 volts. So where you now have the open circuit voltage. So I'd like to give you that diagram. And this is the transformer. And this is your input. And here you have 230 to 250 volts. Alright? Now, in place of your output, you have this as a transformer. Now, in the case of your output, discover that you will now be having, when the transformer steps to, you will now be 100 to 80 to 100 volts. So this is now your output, and it's ready to be used. Now, how does this voltage play an important role in welding? Stability of the arc comes from the voltage. So it means that if your voltage is low, it means the arc will not be stable. You have a situation whereby your arc, in this case now, this is a step-down transformer in the welding machine. This case, this is the step-down transformer. So the step-up transformer, what it does is that it sets up the voltage. So when your voltage is low, you have issues with stability of the arc. So you have an arc that is unstable. the arc is unstable, so it's always going off. The electrode begins to stick. But when you now have a voltage that is too high, you discover that your bead will be flattened. It will be very flattened. That's one challenge you have when you have a voltage that is too high. And then, but when your voltage is normal, you discover that your penetration will be normal, your bead will be very normal, and everything about the well will be also normal. So that is how to determine the amount of current that is required for your well. See you in the next video. But please don't go without subscribing, liking, and sharing this video. Thank you.